Now, when we do these, we might not end up with an exact substitution. What do I mean by that? Let's take another one of these things. I will look at the indefinite integral again. Only this time my integrand will be, let's say, sine of 2x times cosine of 2x, all dx. Well, this is helpful again. I can see pretty clearly that I've got a function sine of x, and I've got its derivative, cosine of x. Well, mostly. Well, let's work with that. Again, I'm going to use the letter U. This is the way that I was taught, but the specific letter that I use here does not matter terribly much in the calculation. And when I make this substitution, I'm changing to the variable U. Everywhere I see sine of 2x, that's the same as writing U. And this also imposes a substitution of my differentials. So every time U changes, x has to change as well. But it's not going to be exactly equal to the change in U. It'll be modified by this conversion factor. So I have to calculate what is the derivative of sine of 2x. It's 2 times the cosine of 2x. Okay. Well, I can work with this, but I see a little bit of a problem here. I can replace the sine of 2x in my integral by u. That's no problem at all. But I don't have enough left over to make a full du. I have here cosine of 2x dx. That's what's left over in my integrand. But the substitution says I'm supposed to have 2 cosine of 2x dx. So what am I going to do in this situation? I'm going to take my equation, du equals 2 cosine of 2x dx. I'll divide both sides by 2. That's it. So if this equation is true, then it's also true that half of a du is equal to cosine of 2x, all dx. And that I can find in my integrand and make the substitution. So this integral is equal to the indefinite integral of u times 1/2 du. Now, you might want to move that 1/2 to be outside of the integral. I can do that because 1/2 is just a constant. When I go to calculate my antiderivative, I need to increase the power of u by 1, divide by the new power, and then I'll have some constant of integration, c. I'm also going to multiply through by that 1/2. So this is really u squared on 4. And if I take some constant that's just a placeholder and I divide by 2, it's still just a placeholder. So just like we did with our antiderivative section, I'm going to say that this is still just plus some constant of integration. It's only there to remind me that there are multiple solutions to this problem, and I would need to solve for this constant based on other parameters. But for right now, I'm focusing on the integral part of the calculation. Now, just like before, I need to change this back into the x variables. So where I see u squared in this formula, u is going to turn back into sine of 2x. Since I'm squaring that, I'll have sine squared of 2x, all on 4, all plus c.